Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a better blind 75 coding series. So today's problem is implement queue using stack. So we have to implement a first in first out queue using stack, using only two stacks. Let's jump into the problem and we'll come back to these screens while explaining. Okay, so last time we have solved linked list cycle from our Grind 75 coding series. Let's solve implement queue using stack. Let's quickly go through the problem statement. Implement a first in first out queue using only two stacks. The implemented queue should support all the functions of a normal queue: push, peek, pop, and empty. They've already given us the skeleton code for push, pop, peek, and empty and MyQueue. So we don't have to make much code changes. Implement the MyQueue class. Okay, we have to implement all these methods. Push element X to the back of the queue. Okay, this is important. Remove the element from the front of the queue and return it. And return the element at the top of the queue, peek, and return empty if it is empty, right? Okay, so before we start solving this, the approach is very clear that we are going to use two stacks to implement a queue. But just for everyone, let's understand why we are going to do this. Okay, so if you know a queue, you insert from one end. Okay, one number is inserted there, the next one would be inserted behind this, behind this, behind this, and whenever you remove the element from the queue, element in the front, so which was inserted first, will be removed first. That's why first in first out. Now how it works for stacks is, it is always last in first out, LIFO. So if we have 10, 20, 30, and if I do a stack.pop, I'll get 30, not 10. On the other hand, for a queue, I would have received a 10. Now stacks, whenever we have to remove from the stack, we remove the top element, but that is not what we want from our queue, right? So when I do a pop operation from these numbers 30, 20, 10, I want that 10 should be removed, right? So what we are going to do is, we are going to copy all the elements from the first stack into a secondary stack. So we copy 30 first to this stack, 30 goes down, 20 goes on second, 10 comes on top, and then we can peek or pop the top element, that will be 20. Similarly, each time we have to then redo the same procedure. For empty, we can directly check. For pushing the element, we can directly push it on top, and every time for peek and pop, we are going to put all the elements into the second stack until this stack is empty, and then we are going to return the top element from the second stack. I hope that's clear. Let's jump to the problem statement. Let's start solving. Okay, so before we start solving, let's create two stacks. We'll call them public stack integer stack 1 and stack 2. Okay, so now we have created two stacks. In our MyQueue method, let's initialize our main stacks. So stack 1 is equal to new stack. Similarly, stack 2 is equal to new stack. So we have initialized two stacks. Let me just comment it for everyone. Initialize main stack, and similarly initialize secondary stack. Okay, now for the push, we want to push it at the back of the queue, as we saw earlier, right? So we can directly actually push the element into this, and while doing a pop and peek, we'll do the transfer from one stack to second stack. So let's say we are going to say push the element to the back of the queue. We are building the queue, right, which is top of stack 1, as stack 1 is our main stack. So we'll simply say stack 1 dot push, the element is X. Done. right? So we pushed one element in our first stack, that is 10, when push 10 came. Similarly, if we get again a push 20, 30, similarly we'll keep adding the elements on top of the stack. Now what happens for the case of pop? Okay, let me put it as comments for everyone. To remove an element from the, where do we want to remove it? From the front, right? From the front of the queue. Why front? Because we want 10 to be removed first, so that it will become the front of the queue. As you can see, we are inserted from the back and we need to remove from the front. Okay, so to remove an element from the front of the queue, we are going to transfer all elements from stack 1 to stack 2. Oops, stack 2. Okay, so we'll say while stack 1 dot is empty. So we are checking for until stack 1 becomes completely empty. We'll remove all the elements from stack 1 and push it to stack 2. So we'll say stack 2 dot push stack 1 dot pop. Oops, pop. Right? So what we are doing is one by one we are removing all the elements from our first stack and putting them into our second stack. So it will become 30, 20, 10. Right? This is done. Then we can simply say int result, the number that we should return is going to be stack 2 dot pop, right? Because here we wanted to remove 10. So first we inserted all the elements from first stack to second stack, then 10 came out on top. If we do a stack dot pop, the first element on the top will be 10, which will get removed. So we'll remove 10 this way. Okay, now once we have removed it, right, let me just add it. The element to be removed is now at the top of stack 2, right? Now once we have removed, what we will do is we'll transfer remaining elements 20 and 30 back to our original stack. So it will become 20 below and 30 on top. So we'll say transfer the remaining elements back to where do we want to transfer it back to? We need to transfer it back to our original stack. So back to stack 1 to maintain the order, right? So that let's say for the use case, I'll write the use case here. Okay, numbers were 10, 20, 30, 40. So with push we started entering them one by one into stack 1, which was 10 first. So our stack 1, stack 2, after doing a push of all the elements, stack 1 would look like 10, then 10, then 20 gets inserted, then 30 gets inserted, then 40 gets inserted, and this is the head of the stack, that is the bottom. Now when we wanted to do a pop operation, this one, we transferred all the elements first from first stack to second stack. So one by one all the elements will be removed from first stack to second stack. So 40 will get removed from here, it will come out here 40, then 30, then 20, and then 10, and this stack will become empty. Now we did a pop operation. Result is equal to stack 2 dot pop. So pop will remove the element from its head, so 10 gets removed. But now to maintain the order, right, to maintain the order, we'll start transferring this element back to stack 1. So one by one we'll remove from here, we'll add 20 here, we'll remove it from here. Then we'll remove 30 from here, add it here, 30. Similarly, we'll remove 40, we'll add 40, right? Now this is to maintain the order, because now next time if we want to remove an element again, if we want to do a pop, we'll again transfer all these elements to the second stack. So 40, then 30, then 20, and 20 will be on top and 20 will get removed. This is the head. Right now 20 is at the bottom. I hope that is clear to everyone. Okay, let's move on. Okay, so we are going to transfer all the elements back to the original stack to maintain the order. So we'll use the same operation while stack 2 is not empty. So we are checking for stack 2 not empty. We'll say stack 1 dot push stack 2 dot pop. So we'll remove the elements from second stack, add it to first stack, and then return result. Okay, so our pop is complete as well. The similar operation is going to take place for peek. In peek, we don't remove the element, we just return the top element, right? So similar operation will take for the peek also. So we'll say to peek at the element at the front of the queue, transfer all the elements from stack 1 to stack 2. Okay, so we'll use the same operation while not empty stack 1 that is empty. So while until stack 1 becomes empty, we'll remove all the elements from stack 1 and push it to stack 2. Okay, right, this is done. Result would be int result is equal to stack 2 dot peek, right? We are not removing the element, we are just peeking the element. We are just taking a look what is at the top of the stack. So the element at the front is now at the top of stack 2. Okay, similarly, to maintain the order, we are going to transfer the remaining elements back to stack 1 to maintain the order. Clear? So we'll use the same operation. We are going to say while stack 2 doesn't become empty, so is empty operation on stack 2, and then we are going to say stack 1 dot push whatever will pop from stack 2 dot pop. So one by one all the elements will be removed from second stack and will be returned back, transferred back to stack 1. Then we'll simply return result. Okay, so this way our peek is completed as well. Peek is same as pop. The only thing is here we are doing a pop operation, so we are removing the elements. Here we are doing a peek operation. Now is empty. So is empty is does not require any operation checks. We can direct since stack 1 is our main stack, we are maintaining our queue in stack 1 and we are using stack 2 just to perform the operations. So whether our queue is empty or not, we can simply check return stack 1 dot is empty. Okay, the queue is empty if stack 1 is empty. Okay, yeah, so let's remove this part. I hope this is clear to everyone. That is all from our today's video. Thank you everyone. For any comments or any questions, Please let me know in the comment section. That's all from 1045 Engineering today. Please like, share and subscribe. Oh, I missed it, sorry. Just we didn't submit our solution. Oops. In a flow I almost missed it. Let's submit it and check. Oh, okay, it's already beating 100% of the users. Of course it would, because we are using the fastest approach possible. Please let me know. Yeah, so now we can conclude the session, and if you have any comments, please let me know in the comment section. Thank you everyone.